Alright, in today's lesson, I'm going to be showing you how to use the calculator to convert complex numbers between the different forms. Okay, now this lesson is strictly meant for level 4 mathematics. Okay, I also think that this lesson is also relevant for level 3, but level 3 it's a bit tricky. It's a little bit tricky because you have to show all your calculations when doing these conversions, but in level 4 showing the conversion is not really that necessary. You just need to convert and perform some calculations. Okay, so using your calculator or learning how to use your calculator to convert complex numbers, it becomes useful when doing calculations, more especially involving the de Moivre's theorem. Okay, now just a little bit of theory here. We have two forms of complex numbers, isn't it? We have two forms. The first one is the polar form. It's the polar form. So this is the polar form, r cis theta, or r and then argument like this, where the r stands for what? Modulus. And then the theta stands for what? Argument. Okay, then second form, it's the rectangular form or the standard form. Rectangular form or the standard form, or the standard form. All right, so rectangular form or the standard form, which is the a plus bi, basically the combination of what? Of the real part and the imaginary part of our number system. Combined, they give us what? A complex number. Okay, there is a way, right? There's definitely a way for manually converting the polar form to the rectangular form and taking the rectangular form back to the polar form. And all this can be done through the Argand diagram, more especially moving from rectangular to polar form, and then from polar form back to the rectangular form. It's the easiest part, right? Because moving from polar to rectangular, what do? We say r cos argument plus I sine argument. This is how we change a polar form to a rectangular form. Now, changing from the rectangular form back to the polar form, you would have to use the Argand diagram. Okay, the Argand diagram. So I'm going to show you how to convert using the calculator, but I just want to go through some of the theory first. Okay, some of the theory first. So let's take an example. Let's just take an example. Let's say here's an example. We are given a, let's say we are given 1 plus I as a complex number. So this complex number is what? Is in rectangular form. It's in rectangular form. So we have to take this and convert to polar form. Take this and convert to polar form. So we're moving it from rectangular form to the polar form. How do we do that? We would have to plot the Argand diagram. Okay, so let me sketch one. Let me prepare one. So this is the Argand diagram, where the x-axis represents what? The x-axis represents the real part, and then this represents what? The imaginary part. It represents the imaginary part. So here it's going to be 1 2 3 1 2 3 4 5 6 7 minus 1, minus 2, minus 3, minus 1, minus 2, minus 3. Okay, so the x-axis represents the real, and then the y-axis represents the imaginary part. Okay, so the 1 is what? Is the real part, and then the coefficient of I is what? Is the imaginary part. That explains the I. The I imaginary. I stands for imaginary, right? Imaginary. So we know that in standard form or in rectangular form, the first number is represented by A, and then the second number, the coefficient of I, represents what? B. Now, in a coordinate system, in our coordinate system, the Argand diagram, the coordinate goes like this. The x coordinate is the x coordinate is A, the y coordinate is what? Is B. Now, what is A in this complex number on our example? It's 1. And what is B in our example? That is also 1. So the 1, 1 is found where? In the first quadrant. Okay? In the first quadrant. Ish. Yeah, okay. I see the problem now. I see the problem. So, you know what? Instead, let me do this. 1, 1, 2, 3, 1. 1, 2, 3. That's 2. 1, 2, 3, 1. 1, 2, 3, minus 1. 1, 2, 3, also minus 1. Okay? I'm trying to open up a scale sum so that when I plot, I don't have something short. Okay? So what I basically did here, I increased the scale. Now let's plot the 1, 1, the 1, 1 coordinate. So that's 1 and 1. And then I connect like this. I connect an arm or a line from the origin to the point that was plotted here. Okay, so remember, we want to convert this standard or rectangular form to a polar form. What is the best way to do it is to sketch a Argand diagram. So this is what we basically did. Now, we have to calculate R. We also have to calculate the argument. The argument is always measured from the real or the x-axis anti-clockwise, right? From the real axis anti-clockwise. Okay. We need the modulus as well as the argument. So let's calculate those two. So R, we know that it's calculated as a squared b squared is equal to R. What is A? A is 1. A is 1. So we're going to have the square root of 1 squared. What is B? B is also 1. 1 squared is equal to. So solving for this, it gives us what? A square root of 2. Okay. Now, since our argument is measured in the first quadrant, so the argument is going to be arc theta b over a. Theta is equal to arc theta, arc tan arc. What is b? B is 1. What is a? A is also 1. Therefore, calculating for this, we get a 45 degrees. So the argument is 45 degrees, and R is equal to the square root of 2. So this in polar form can be expressed as this: R cis theta, polar form. What is the modulus? The modulus is square root 2 cis. What is the argument? It's 45 degrees. So this is what we basically calculated as our 1 plus I converted to a polar form. So this is an equivalent of that, okay, but in another form, which is the polar form. Now, let me show you how to use a calculator. Let me show you how to use a calculator to convert from a rectangular form to a polar form. All right, to a polar form. So do you see how how long the process was in order to convert to a different form, to convert a rectangular form to a polar form? We had to find r, we had to find the argument as well. Okay, so now I'm going to show you the calculator. I'm using a calculator. So just note this somewhere, note this down somewhere. Okay, I'm going to hide this for a moment. I'm going to hide this for a moment. Now, this is a calculator, right? This is the most common calculator that I see amongst my students. Okay, so I'm going to assume that whoever's watching this video, um, I'm assuming, remember, I'm assuming that they also have a calculator almost similar to this one. Okay, but what I've noticed as well is that most of the Casio calculators, they have the functionality that I'm about to show you. Okay, they have the functionality that I'm about to show you. But so, in other words, this video is somewhat limited to only the Casio calculator. If you have a different calculator, well, it's unfortunate. It's unfortunate for you. So, I haven't used any other calculator besides the Casio calculator in my school life, my high school life, in my university life. I've always been using the Casio calculator. It's not like I'm discriminating the other brands. It's just it happens to be part of my academic life. Okay, so this is what I know, guys. I'm gonna share with you what I know regarding this issue of conversion for complex numbers. Okay, now this is the common calculator, right? I'm assuming that you are using this one. However, I'm also using a different calculator here. Now, it's the same brand, yes, but the models are different. The one that I'm currently using, there's actually a mode that you can use and calculate complex numbers without having to go through the route that I'm about to show you, right? But the black calculator doesn't have the mode or the feature for handling complex numbers directly, right? So look, above the plus sign, you should see the pole, right? You should see the three-letter word pole, and then above the negative sign, you should see the three-letter word rec, right? So the rec stands for rectangular form. The pole stands for polar form. Okay, so we're going to be using these functionalities to convert. Okay, remember the example that we had. The example was this: take 1 plus I and convert to a polar form. This is a rectangular form. This is in rectangular form. We want to convert it to a polar form. Okay, we want to take this and convert to a polar form. All right, so in order to change this to a polar form, we would have to use the pole functionality. All right, so how do we punch this on the calculator? We say shift, okay, let me cancel. We say shift, then we press pole. We press polar form. So what the functionality does, it says we are taking whatever is inside the bracket and converting it to a polar form, right? So the polar form, we know that in the context of an ordered pair, right? In the coordinate system, the rectangular form would be written as AB. Then what is A? It's 1, and then what is B? That's also 1. All right. So the calculator accepts polar, it accepts ordered pairs. What do I mean? I'm saying that when you insert your values, you insert them as 1 and 1. So we want to convert this rectangular form to a polar form. I want to convert 1. Now you don't use it's not a full stop. You don't use a point. You would have to use look, there's a comma here above this bracket, right? Above this bracket. Now how do you insert that? You go ahead and say shift and then you press this, right? You press this. You need a comma, not a dot. Not this one, not this one. You need the one above the bracket. All right, so hence I'm saying shift, press this button, and then let's press 1, then you close the bracket. The answer is this. The answer is this. R is equal to 1.414, which is the same as the square root of 2. Take your calculator and say square root of 2. You should obtain the answer, the same answer as this one. All right, and then theta, the argument, it's 45 degrees. It's the same value that we got before. It's the same value, same as the value that we got as before. So in in polar form, this can be written as R cis argument. What is R? R, that is 1.414 cis. What is theta? The argument is 45 degrees. This is no different from the square root of 2. So whatever we had before, whatever we calculated before, we're using the Argand diagram, is the same as this, right? So this is how you use your calculator to convert from the standard form or the rectangular form to the polar form. Okay. If I take this out, okay, you know what? Let me erase instead of erasing the entire thing. Okay, let's take a second example. Example number 2. All right. So in example number 2, let's do this. We have a complex number of square root 2 cis 45 degrees. Take this and convert it to a rectangular form. A rectangular form or standard form. Okay, so manually how do we do this? So we can convert this without the use of first I'm going to show you how to do it without using a calculator. Then I'm going to show you how to do it using a calculator afterwards. Now this is going to be the square root of 2 open bracket cos 45 degrees plus I multiplied by sine 45 degrees equal to, all right, then you take this r and then you multiply with it inside the bracket. You're going to have a square root 2 cos 45 degrees plus I multiplied by the square root of 2 multiplied by sine 45 degrees. Okay, then you punch this whole thing into your calculator. Now we're gonna have the square root of 2, and then let's go outside the bracket and say cos 45 degrees, that's 1, plus we punch this whole thing again. Instead of having a sine, I have a cos. No, instead of having cos, I would replace that with sine. I'm also getting 1. Remember, there's I in front of this. So I times 1. This is equal to 1 plus simply I. Alright, so you remember this from our previous 2 examples, right? So this was 1 plus I initially. I showed you how to convert it, how to convert this to a polar form. So now we are taking this and converting it back to standard form, which is the same as before. Okay, now let me show you how to convert this using a calculator. So we have the square root of 2 cis 45 degrees. We want to convert to rectangular form. Okay, let's bring up the calculator now. All right, so I want to take this and convert to rectangular form. We are now going to use the rectangular functionality. Okay, so on your calculator you're gonna say shift rectangle. Let me hide this for a moment. Okay, again you're gonna use ordered pairs. So to convert to a rectangular form, what you have to do is you need the modulus as well as the argument. What is the modulus? It's the square root of 2. What is the argument? It's the 45 degrees. So on your calculator, this is what you're gonna punch in. So you're gonna say rectangular. I wanna take whatever is inside the bracket and convert to rectangular form. So we're gonna say square root 2, shift, press here so that you get this comma. Let's bring back the calculator, and then you're gonna press 45, then we close the bracket. X is equal to 1 and y is equal to 1. Remember, on the Argand diagram, the y is the imaginary part, the x is the real part. So on the calculator you can see that x is equal to 1, y is equal to 1. X is equal to 1, y is also equal to 1. So in standard form, the calculator gave us this 1 plus I. 1 plus I. Remember, the standard form is a plus bi. Okay, a plus bi. So the a is the same as y, the b is the same, the a is the same as x, and then the b is the same as y. Now, which brings me to this rectangular form, 1 plus I. So this is how you do the conversion using your calculator, your Casio calculator. I don't know about the other brands, guys. So yeah, okay, so in one of my recordings, this is what I had in one of the previous questions. I'm not sure. Nope, it's not this one. This one, yes, it was this one. So there was a level 4 question paper that I was answering. I have one of the videos on this channel. I'll also leave a link to the video. I'll leave a link to the recording for this question. Okay, but I just want to explain more, especially these two parts. Okay, so these two parts, more especially the numerator part, this part, it required us to use the De Moivre's theorem, right? So in the De Moivre's theorem, we can only apply it over a polar form, right? Over a polar form. Now, if you read through the question for 1.3, it says simplify the following complex expression and write the answer in this form. Use 3 decimals and leave the answer in polar form. Okay, yeah, this was the confusing part. No, so we're gonna erase this part. Let's erase this part and say use 3 decimals and leave the answer in polar form, not in standard form, but in polar form, where the theta is between 0 and 360. Calculations in rectangular form are excluded. Okay, anyway, so our answer should be left, or we should leave our answer in polar form. So everything standard or rectangular in form should be converted to polar form. And this we have no other choice but to convert it to a polar form because it's De Moivre's theorem. All right. So on the question, I said, okay, us taking this and using the Argand diagram to get the polar form, it's gonna be a lengthy process. So I was like, okay, you know what, just use your calculator. Now I'm showing you the part where you get to use the calculator in getting your polar form from this. All right. So going back to our calculator, I now want to convert this complex number to a polar form. I'm gonna say shift polar. What is A? A, that's 1. Shift. What is B? That's -1. Close bracket. Now you can see that R is 1.414. Cis, let's go check the argument. The argument is -45. Open bracket, -45 degrees. Close bracket, raised to exponent 5 multiplied by 2 says 30 degrees over, and then you do the same thing with the other one. We have to start the process again. Shift polar, whatever is inside the bracket, whatever I'm gonna insert, I want to convert it to a polar form. So it's 12 shift comma -8 close equal to, so we have 14.4 to 2. Says, what is the argument? -38, 33.69. -33.690. So this is how you use your calculator to convert complex numbers. You know what to do from here, right? De Moivre's theorem, then you simplify accordingly. So I'm not going to simplify this. All right, thanks for tuning in, guys. The purpose for this video was just to show you how to convert complex numbers between the different forms using your Casio calculator. I hope you enjoyed. I hope you took some value out of this discussion. Let's talk in the comment section if you have any questions. For now, signing out. Peace.